Okay. All right. Question 4. Two real numbers are selected independently at random from the interval -20 to 10. What is the probability that the product of these numbers is greater than 0? Sharma, were you able to do this one?
Yeah, I got 5/9.
5 upon 9.
So, two things. Is this homework 6?
Homework 6, yes.
Also, you aren't sharing your screen.
Oh, I'm not. Okay, sorry. Thanks. Yeah, homework 6, we have to finish this latter half, and then homework 7 after that. Yeah. Vihan, did you also get the same answer for question 4 as she stated? 5/9 is what
Yeah.
she got. 5/9 as well? Vihan? You said yes.
Yeah.
Oh, okay.
Yeah, I'm
all
just
right.
opening up the worksheet and my
Okay.
book.
Yeah. So just so that. So first of all, it says selected independently at random, right? So independently means, Ananya, do you think this with replacement or without replacement?
Without.
Without replacement. So why would without? Okay, why would? Okay, all right. Let's go through your working. How did you arrive at 5/9? I'm not saying it's right or wrong, but yeah, how did you arrive at it?
For it to be a product of two numbers, either they have to be both positive or both negative for it to be greater than 0.
Correct. Agreed.
So then the number of both, like the number of negative numbers was 20 upon 30. The total was 30 because, and then there are 20 negative numbers, and then there are 10 positive numbers.
Okay. What about 0? And what about fractions? Like it
Also,
says real numbers, right? So 7.8 and 2.1 could have been picked up as well, right?
oh,
Okay.
I take that into.
Okay. Yeah. So we'll discuss all that. So there are a few things happening. It's real numbers, not just integers. And then further, how do you account for 0? And if you're talking integers, there are 31 numbers from -20 to +2 and +10, including both. There are 31 numbers, not 30. Right? So you have to treat. So in a way, dealing with integers is a little harder. We'll do that also. Right after this question, I'm going to change the question and say, not real numbers, integers. Now do the question, Karke. But for now, with real numbers, okay, so you unintentionally did that, but it just happens to be 5/9 as well, is the correct answer. Because, okay, right now the number line is here and 0 is sitting here, let's say, right? So there is a gap of 20, a length of 20 where which you could pick a positive number. And there is a gap of 10 where you could pick a not real number. A gap of 20 where you could have picked any positive real number, and a gap of 10, a length of 10 where you could have picked any negative real number. Okay, so like you rightly said.
Reverse, sir? Isn't it 20 negative and 10 positive?
Yes, you're right. You're right. Okay. Anyway, the conceptually it's the same, but yes, you're right. So it's starting from 0 here, right? So 0 is here. Okay, so 0 is here. So this 10 positive and 20 negative. Okay, so on the positive and positive is the fraction of the infinite set of points here, which are positive, infinite set of points which are negative, but relatively we can quantify what fraction it is. So fraction 1/3 of numbers are positive, and for it to be 1/3 into 1/3, right? And actually selected independently means without replacement. Sorry, with replacement, right? The whole point of, again, it does not matter here because there's an infinite set of points. So even if you pick a point and do not replace it, it does not matter because you have countless points. So if you pick 7.8 and you don't replace 7.8, or rather 7.832, let's say, and then don't replace it, it's not going to matter at all. But when we do with integers, it's going to matter, as we'll see in just a bit, right? But in general, Sharma, if it's independent, that means it is with replacement. Because just imagine, suppose it's countable, as in not infinite like this, but let's say integers. Again, I keep saying I get ahead of myself, but suppose it's integers, which means, let's say you've picked 7, right? And if you don't replace, then you are influencing what is going to be picked next, right? There's fewer positive numbers for you to pick from. So it's not an independent selection in that case, if you do not replace. Only if you replace, you guarantee independence. Does it make sense, Ananya?
Yeah.
Okay, so logically it should make sense, right? Not just because you don't have to memorize, right? Just imagine if you replace it, put it back, then you're restoring independence, because really you could get the same number also again, right? There's no influence. Whereas if you don't replace, your act of picking 7 has influenced those fewer positive numbers now. Okay, anyway, point taken. So back to this question, where it's the infinite set of numbers. So it's 1/3 into 1/3 for the positive part and 2/3 into 2/3 for the negative part, right? So it could be a positive number and a positive number, or a negative number and a negative number, right? Sorry, you were saying something? Kunsh, you were saying something?
No, sir.
No, you're okay. Okay. So therefore it is 5/9. Okay. So I would say it's coincidentally right, Ananya. Sharma. Okay. The other Ananya is missing, so I can call you Ananya today. She has exam. Okay. Okay. Now let's modify this question. So I'm going to suggest a couple of modifications. First modification, I'm going to replace 2 integers. Okay, are selected independently. So if I say independently, then it's automatically assumed that I'm replacing, as I just said. Otherwise, they won't be independent, right? So selected independently, which means I'll just say, which means with replacement. With replacement. Agreed? Can we all do this question, this variant, and then come back with an answer? All of you try this. Okay, Anahat, you have something for me?
Also on the answer calculator.
It should not take so long, guys. I'll give you another 30 seconds still. Anyone who has done can call out. Kunsh, come on, tell me, help me.
So I haven't simplified, but I got 500 over 961.
Okay. Anyone agree or disagree with him?
The same thing.
Same thing, right? Yeah.
Because-
And the, go ahead, Ananya.
Because you said you would include the 0 to 31 number.
Exactly. Yeah. There's nothing further to simplify here, Kunsh, because 31 is a prime number, so you cannot, right? So as you rightly said, 20 into 20 plus 10 into 10. Just the denominator is not 30 into 30. Now it's 31 into 31. So the probability is less than 5/9 that we saw earlier, because the 0 was not influencing so much earlier because it is one among the infinite points. So the contribution from that was 0, literally, as the name itself says. Actually speaking, contribution of every single point was minuscule, but collectively we arrived at a number. But in this case, 0 is one of the 31 numbers. It has significance. Like 1 out of 31 is like 3%, right? Roughly. So it has influence, and which is why if 0 is in the mix, then the answer will be 0. But you want the product to be strictly greater than 0. And therefore, you have a lesser chance than 5/9. Does it make sense, all of you? Okay. Vihan and Anahat, you got the same answer as well, eventually?
Yeah, so I was trying to simplify it, but then as you said, you couldn't.
Yeah, because 31 is a prime number, right? So this is 31 into 31. 31 won't cancel off with anything. There's nothing further to cancel, right? So 31 into 31 won't cancel with 500. Okay, now again integer, and now I'll say, I won't say selected independently. I'll say selected without replacement, right? Earlier was with replacement. So without replacement, which means there is dependence, which means I pick an integer and then I pick another integer. Now do the same problem. First of all, do you think the probability will be less than the 500 by 961 or it will be greater than that? What does intuition say? I want some intuition first.
Actually, sorry, greater. Yeah, greater. The denominator will be less. Sorry.
Sorry, Kunsh, finally, what is your final thing? Is it greater or less? So is the answer, so we did
Greater probability.
greater probability for this latest question. Why do you think so?
Wait, it's because
Won't the denominator be less?
yeah, because the
Numerator also
denominator will be
numerator will
less.
also change, right? Numerator and denominator will also change, right?
Yeah.
True. So it's about, which will make a greater impact, the change in numerator or denominator.
Okay, so the way to think about it is this, right? For the product to be positive, both have to be positive, correct? If you pick
Yeah.
one positive, in the previous case, you replaced it back. The probability of picking another positive was still the same, correct? But now
Right.
we are not replacing. If you pick a positive, for the second draw, the probability of picking another positive is gone down. And same with negative. If you pick a negative, the probability of picking another negative is gone down. Therefore, this probability, the latest one, will be lower than the one before that. Does it make sense? Yeah, and you'll see it for yourself. Work out a number and just tell me how much this will be. Simplify this, guys.
So would it be 22 over 61?
22 over 61.
Yeah.
Okay, so this is approximately, how much is this? If I have to do in 1.5, around 30%, you can say? Or no, 1.5, around 35%, right? Around 35%, correct? So what did we get earlier? We got 500 by 961, which is around, roughly around 55%. I don't think it'll be so much smaller, right? Anyway, we'll work it out. It seems too small to me.
Maybe
So I got 47 over 93.
Yeah, I got the same thing. But I
Same
don't
thing as who?
47 upon 93.
47 upon 93.
Some
Okay.
of them will cancel out.
Okay.
even.
So 47 upon 93 is how much in percentage? How much does it work out?
About 51-ish.
Can you do it on the calculator, guys? Tell me what is 500 by 961. Tell me also what 47 by 93.
0.52 is 52% is 500 by 961.
And this latest one, 47 upon 93 is?
0.51.
So 51%. So it's 52% versus 51%. Is that what you're saying, Vihan? It's slightly lesser, right?
Yeah.
As expected. So it's lesser, right? Okay. So let's work it out. So, effectively, multiple ways of doing this. So first, if I have to pick a positive number, it's 20 over 31 into 19 over 31. Or sorry, if I have to pick a negative number, negative and negative. So it's 20 of the 31 times 19 of the 30, or 10 of the 31 and 9 of the remaining positive numbers from the remaining 30. That's it, right? So this will be 930, and this will simplify to whatever, 380 plus 90, which is 470. So indeed, it's 47 upon 93. Does it make sense? Anath, what was the mistake?
I got the same first equation, but I think I made some mistake in calculating multiplying something.
Okay. Another way to arrive at the same thing. So I'll have to choose two numbers. All right. The bottom is 31, choose two. I'm choosing two means what? I'm not replacing, right? I'm selecting. And then after a microsecond, I'm selecting. Choosing two, you can just imagine, just drawing two from a bag means what? It's actually without replacement. You're not realizing with or without because you're grabbing two, but just imagine you're grabbing one and a nanosecond later you're grabbing another. That's what is happening when you draw two. It's actually without replacement. When you're grabbing two, that means it's without replacement. Are you able to imagine this? Right? It's without replacement. So 31 choose 2 is the denominator, and in the numerator, the possibilities where we have picked two negatives or the possibilities where we have picked two positives. So So this will again simplify to the same thing, but I'll just show you that it does. So 20 into 19 by 2. And sorry, this is 10C2. Sorry, this is 10C2. Right? And this is 10 into 9 by 2. 10 into 9 by 2. Whole upon 31 into 30 whole by 2. So if you divide the by 2, by 2, by 2 everywhere, it's exactly same as the previous expression. 20 into 19 plus 10 into 9 upon 31 into 30. Okay, does it make sense? All three variants? Okay, good. That was question 4. Question 5.
Question 4.
Yeah.
Earlier you said the real number, it was just a coincidence that I got the same. So how would you solve it?
We did for the real number, right? Didn't we?
Yeah, but so you said it was a coincidence because we didn't take
You-
into.
In fact, you should tell me how you got 5 by 9. So you got 5 by 9 by just doing,
But yeah, but
you-
2
you-
upon,
sorry, what is your logic for 2 upon 3?
so that 2, like for the negative was for 2 to get 2 negatives, the probability was 2 upon 3.
Correct.
And then
It indeed is 2 upon 3. But your logic was, you said there are 20 negative numbers. There are 2 zillion, or not even 2 zillion. There's infinite negative numbers and infinite positive numbers. But fraction wise, it's 2:1. The mistake you made was you said, I got you when you said there are 10 positive numbers and 20 negative numbers of the 30 numbers, right? You were thinking integers, integers, integers. Plus the double mistake that you made was you did not count 0 at all, right? So which is why you got lucky. You did 20 upon 30 into 10 upon, or 28 upon 30 into 20 upon 30 instead of upon 31, right? You did think of integers while solving this question, right, Ananya, initially,
Yeah.
right? But you made 2 mistakes. That the denominator, you did not count 0, and therefore denominator was wrongly 30, right? But it helped in the sense. Does it make sense? Okay. Sure, right? Completely okay, right? On this? No? Okay. Question 5. Okay. Kunsh, what did you get on this one?
1 over 36.
1 over 36. Okay. Vihan,
Yeah, sir.
what did you
Even I
get?
got 1 over 36.
Okay. Same Anahat and Ananya, what did you get?
We got 1 over 12.
1 over 12. Okay. Anahat, did you do this as well?
Yeah, I got 1 over 36.
You also got 1 over 36. Okay, let's see. A pair of 6-faced dice rolled once. Okay. Sum of numbers determines the diameter of the circle. Okay. So, and what is the numerical value of the area of the circle is less than numerical value of circumference of the circle. So what is the area? Area is pi r square. So which is pi into diameter by 2 whole square. Should be less than 2 pi r. R is d by 2. Okay, so let's simplify this. Pi gets cancelled, 2 gets cancelled, which means we want d square should be less than 4d, and d is all positive numbers here. Therefore, d should be less than 4, which means d is the sum of the 2 numbers, right? So the numbers in a pair of die can range all the way from 2 till 12, which means it can only be 2 or be 3. How can you reach 2? By combination of 1 and 1. How can you reach 3? By a combination of 1, 2 or 2, 1. So there are 3 outcomes of the 36 outcomes in a die. So indeed, it's 1 over 12. Ananya, well done. How come 3 mistakes? All 3 of you guys got 1 over 36. What happened, guys?
So I forgot that 3 also fits the requirements. I thought only 2 did.
Okay.
Because I didn't do a formula wise. I just used logic and I messed up in that.
Okay. So you said 2 was the only possibility. So d less than 4. You just thought d has to be just 2. Okay. All right. I mean, if at all anything, the mistake just more likely is people would count 4 also by mistake. D is less than, strictly less than 4 and not including 4. But I cannot imagine how you slipped 3. What about you guys? Vihan and Anahat, what was the mistake?
So I made a very stupid calculation mistake.
Yeah, which is?
So I just firstly I didn't I made 2 mistakes. The first one was that I just took 1, 2. I didn't take 2, 1. And then the second mistake was I did 2 divided by 36. I just don't know why I wrote it as 1 divided by 36.
Vihan beats me. Each silly mistake worse than the other. Okay. And not just Vihan, everyone, right? Guys, you have to watch out on silly mistakes. It's not cool to do silly mistakes. Ultimately, what's going to matter is is it right or wrong, right? And then after doing all the hard work, if you mess it up at the last stage, then these are all easy, like laddus, right? You cannot afford to make mistakes. Okay, anyway, that was question 5. Please watch out, guys. Question 6. Anahat, I didn't even ask you, but hope something very similar to their stories. One silly mistake on 1/36. On the previous one, Anahat, you also got 1/36, right? You said?
Yes.
Okay, all right. Same story, something horribly wrong. Fine, it's okay. Okay, question 6. Ananya, what did you get on this one?
I didn't understand this one.
What do you mean you did not understand specifically what? Equally
So,
likely
like,
to land
how you
anywhere.
would. So if it's equally likely to land, wouldn't it just be like 1/9? I don't think.
1/9
Ah.
9 because there are 9 divisions. Is that what
But
you mean?
I don't think it's.
No, but that's the
correct.
first thing that came to your mind because there are 9 divisions and therefore 1/9. That's what you were going to say initially.
It's equally to land everywhere.
Yeah,
But I
it's
don't
e-
think it's.
it's equally to land in every small little pixel on the board, not every one of those big boxes, but he's saying equally likely to land in this spot as it is to in this spot, as it is in this spot, as in this spot, this spot. There are zillions of pixels here. So it's not like equally likely to land in each of these big 9 compartments. Then it'll be 1/9, which is nothing, right? It's just counting, right? But equally likely to land in each of these pixels, which means just like the previous question was a ratio of lengths, here it's ratio of areas. In probability, they're all infinite. The number of points in the real line was also infinite. Here also on a surface, the number of points on this surface is infinite, but I can relatively talk about my preferred surface upon the total surface, right, Ananya? Does it make sense? So all we want is the area of the small little square, not small, the big square, I should say, at the center, upon the area of the entire thing, right? Does it make sense? Conceptually, does it make sense now? Okay, and now rest is just, we just have to calculate the area and just work it out, right? Has anyone done it? Vihan, did you do something and get an answer?
So even I wrote 1/9, but then I realized that they are different. So what I tried doing was I tried giving the
Okay,
side lengths.
can you all do it now? Now that you know what to do, can you all do it? Unless Kunsh, you have an answer, do you? Have you done something and give a hand?
I have an answer, but it's very like very rough day's work, which is 2/7.
2/7. You want to redo it, or what do you want to do? You want to call out that as your
I
answer?
want to redo it, sir,
Okay,
because I
okay,
expect
redo it, guys. Okay, Ananya, you know, understand what to do now, right? Can you work it out now?
Where would you?
Okay,
start?
where would you start? Okay, I'll give you a hint, right? So Ananya, tell me, what is this angle?
So like 45?
Why is it 45? Because it looks like 45, or
Because it's a right angle triangle.
yeah, right angle. But why cannot this be 40 and why cannot this be 50? You know, it's right angle.
So because it's a transversal.
What transversal?
So basically, it's cutting a 90-degree into half.
Which half?
The one that would either wait, I'll just download it. Wouldn't this
so
just be cut
because
into half?
so
Yeah.
we can know that it's 45-degree angle because if you use the formula to find the internal angle for each of the things, it's 135, and we can very likely assume that that is the right angle triangle and the thing below it. So that is 45 degrees.
Yeah, it's a regular octagon, as he said, and therefore each external angle is 360 by n, right? And a regular polygon of n side. So each external angle is 360 by 8, which is 45 here, right? So all of these angles are 45, 45, 45, right? And yes, like he said, right, by symmetry, all of these are perpendicular lines only, right? You can see that they're all perpendicular lines. And therefore, each of them, or other way, what he suggested was each internal angle is what? 180 into n minus 2 is the sum of all internal angles divided by n. So if you do this way also, you'll get each internal angle as 135 degrees. Either way. So you get this as 135 or the other one as 45. And hence from there you can back calculate everything is 45, 45, 45. And now that's one. And the other thing you need to know is in a 45, 45, 90, the ratio of the side lengths is A is to root 2A. 1 is to root 2, right? You know that, right, Ananya? From one of the earlier sessions. If you missed it, you might have seen the video later. But one of the very basic things, right? 45, 45, 90, the ratio is 1 is to root 2. In a 30, 60, 90, that's also equally important, is 1 is to root 3 is to 2. So if this is 30 degrees, and this is 60 degrees, and this is 90, the side lengths are 1 is to root 3 is to 2. So now in this case, it's 45, 45. All the angles are all 45, 45. So it's going to be a bunch of root 2s, and that's it, right? Can you work it out and tell me an answer now? Enough to get you started, Ananya?
So I can, yeah, try.
Okay, try, please. But does this make sense? How you arrived at, we arrived at the angle is 45 degree. Yeah. Okay. Simplified, guys. Got something? How much time more?
I'm getting an answer, but it's based on some assumptions. I'm not sure how to do it without.
Okay. We'll discuss. What assumption are you doing?
That the side length of the triangle is equal to 2 side lengths of the rectangle and the square.
Side length of the triangle. Sorry, please say that again.
Sure. That one side length, that basically the side length of the rectangle is twice the side length of the triangle.
Why do we have to make any such assumption? Okay, let's start, guys. So this is 1. Let's say I can start with anything as 1. I'll make the side lengths of the octagon all 1, right? It's a regular octagon. Therefore, all of these are 1, 1, 1, 1, 1, 1. I don't need to mark all of them, but I'll just mark anyway. Okay. So this is 1. And then I'll take any one of these triangles, right? So we know the ratio is 1 is to root 2. So the one that's in red is actually the hypotenuse. And therefore, this guy will be 1 upon root 2. So that the ratio is 1 is to root 2. Do you agree? This is 1 upon root 2. Ananya, do you agree as well? And that's it. All we need is just this, right? So the total area, so the area at the center is literally like 1 into 1, right? The square is just 1 into 1. which is 1. And the area of the entire octagon is the square at the center, which is 1. Plus, there are 4 rectangles, right? And namely this rectangle, this rectangle, this rectangle, and this rectangle. Each of these rectangles has a side of 1 and 1 by root 2. And there are 4 triangles. So this triangle, this triangle, this triangle, this triangle. Each triangle is half into base into height, half into the base is also 1 by root 2. The height is also 1 by root 2. Right? Let's simplify this. Root 2 into root 2 is 2, and 2 into 2 is 4. So that nicely cancels. And then I can write 4 as 2 into 2, and then I can cancel one of the root 2's. So I have 1 plus 2 root 2 plus another 1 in the denominator. So which is 2 plus 2 root 2. So ultimately, therefore, this is 2 plus 2 root 2. So therefore, the probability I'm seeking is just 1 upon 2 plus 2 root 2, or rather 2 into root 2 plus 1. Right? Does it make sense? I can leave it here, depending on what the choices are, or very likely they'll won't want to leave roots in the denominator, right? I'll multiply by the conjugate. So I'll multiply and divide by root 2 minus 1. So this becomes 2 minus 1 in the denominator, which is 1. And in the numerator is root 2 minus 1. So it's root 2 minus 1 upon 2. Okay. Root 2 is approximately 1.4. 1.414. 1.4 minus 1 is 0.4. So 0.4 by 2, which is roughly around 1/5. And I'm doing this just to get a feel. You should get a feel that this looks like 1/5 of the entire object. We cannot get a super feel, but yes, it's not like 1/10 for sure. It's definitely bigger than that. And it's not as big as 1/2 or something. So it seems reasonably okay. That's 1/5 is a reasonably okay answer, right? Just a very basic rough sanity check is always important. All okay? Make sense? Kunsh?
Yes, sir.
Okay. Anahat, Vihan, you guys are okay as well?
Yeah.
Okay. So this is question 6. Question 7. This was a good one. Okay. Bernardo randomly picks 3 distinct numbers, right? Which means it's like without replacement. From this set, 1 to 9. This guy, Sylvia, picks from 1 to 8. Both arrange them in descending order to form 2 different, 2 3-digit numbers, right? This guy forms to a 3-digit number. This guy forms. So for example, this guy selects 2, 9, and 4, let's say. So he'll form a 3-digit number, which is 942. And the other guy selects 1, 8, and 5, let's say. So he'll form the 3-digit number 851. And then he'll compare 851 is big or 942 is big, right? So in this case, 942 is big, Bernardo's is bigger. But always write out an example so that you have a good idea of what's happening. So this was one example. Okay, how to proceed with this, guys? Any idea?
So
Yes.
I'm not sure if I'm correct, but for overall, Bernardo will have 100 more numbers to make, right?
Okay, so let's see. So
But unless he cannot repeat it, he will always have 100 more numbers.
yeah, so he has 9 choose 3 ways of selecting. This guy has 8 choose 3 ways of selecting. So we can work it out and see what this is. 9 into 8 into 7 by 6. This is 8 into 7 into 6 by 6. So this guy has 56 choices.
56.
This guy has 84 choices, not 100 more, but 28 more, right? So he has 84 choices. This guy has only 56 choices. Why did he come up with 100?
So I thought that if, because he has 9, so he can go all the way from 900 to 999. But oh no, wait, here it's distinct numbers, so he can't repeat.
3 distinct numbers. Yeah.
Yeah.
Okay. Okay. So clearly Bernardo has an advantage because he has a 9, right? So let's do one thing. Let's first solve the problem where he does not have this advantage. Let's say he is also 1 to 8. and Sylvia is also 1 to 8. Okay, it's a relatively simpler problem. Can you guys target this one first? Both have 1 to 8, 1 to 8. How will you do this? Just 1 second, I'll be back. Huh? I'll just have to wipe my. Okay, so if it's 8 and 8, it's symmetric. How do we approach this one? Any ideas?
Wouldn't it be the same probability for
So-
both of
So if it's 8 and 8, Ananya is saying the probability will be half. Is that what you're saying, Ananya? I mean, I'm just questioning you. Don't read too much from my question. It may be right, it may not be right. Okay. Kunsh, do you agree with her or disagree with her? It's symmetric, right?
Yes, I also believe it with 50.
But it's not half each. Why not? Read the question. What is the probability that we are seeking? Ananya, can you read the question aloud?
They could have the same number.
Exactly. We want the probability that Bernardo's is larger than Sylvia. What you said is partially right. Probability for Bernardo to be larger than Sylvia is same as probability that Sylvia is larger than Bernardo. That's symmetric. But there's also a probability, as Anahat rightly said, they could be equal as well, right? So, in other words, okay, so let's say the probability, we'll do this shorter question, right? Where it's 8 and 8. Okay. So let's say probability of B greater than S and probability of S greater than B. So let's say this is some probability small p. Then by symmetry, this will also be the same probability p. That I agree, Ananya. But there's also probability that B equal to S. So let's say that's E or something, right? E equal probability, right? For them to be equal. So this total sum 2p plus E would be 1. Because one of these 3 events has to occur for sure. So the probability that we are seeking is 1 minus E by 2. If you are able to find E, which is the probability that both pick the same number or both numbers are same, in the sense effectively both pick the same triple of numbers. The order does not matter. He picks one, the first guy picks 1, 8, and 6. The other guy picks 6, 1, and 8. It doesn't matter. Both of them are going to form 861 and 861. The two will be equal, right? What is the probability of this happening, guys? Can you tell me? So if you find E, we are done. That's it. What is the probability that both the numbers will be same? Both the 3-digit numbers after arranging in descending order will be same. Anahat or anyone?
Wouldn't it just be 1 minus 2p?
But we have to find, we are using E to find P because E is easier to find, right? It is 1 minus 2p, I agree. But we don't know P. In fact, we don't know P. Therefore, we want to resort to E, hoping that E is easier to calculate. Does it make sense, Vihan? Yeah. So now the easier problem of finding E, what will E be in this case? What is the
1 over
probability?
36.
1 over 36. Why?
Because there's 6 ways to arrange 1, 8, and 6.
Okay. First of all, where is arranging coming here? If you pick 1, 8, and 6, both of them are going to generate 861. So whether you pick 1, 8, or 6, or 6, 1, and 8, I just showed an example where
Oh, yeah,
Bernardo,
because it's in descending order. Sorry, sir.
descending order. The ordering does not even matter. He's just putting his hand and picking 3 numbers. This guy is putting his hand. So which is why I drew it like within a circle. So there's no sense of ordering, right? Random collection of 3. This guy has a random collection of 3. They arrange in descending order. Yeah, Ananya, what do you think? What is the probability of
I'm not sure.
Okay, Kunsh, any idea? Oh, sorry, Bihan, any idea?
Will it be?
Go ahead. Anywhere, any of you. Yeah, go ahead, Kunsh.
Will be 1/8 multiplied by. Actually, wait, no, that doesn't make sense. I'm not sure.
Okay, Anahat, how about you? What is the probability for E? What is E? You're on mute, but you're unmuted, but I could still not hear you.
Just 1 second.
Yeah. It is not difficult, guys. You should be able to come up with this. We have done enough number of questions for you to get practice. Just think logically, kya ho raha hai socho. Just put yourself in that situation. You're playing a game. Bernardo and let's say you're Sylvia. Okay, Bernardo and you. Bihan, come on. Yeah, Anahat, you have something? No? Okay, let's discuss. I think you guys are making too much out of this one, right? It's actually simple, right? So Bernardo is picking 3. And then Sylvia has to pick the same set of 3, right? How many ways can Bernardo pick 3? We already worked through that, right? It was 8 choose 3, right? 8 choose 3. How much was that? 8 choose 3 was 8 into, oh, I erased this just now. 8 into 7 into 6 by 3 into 2 into 1. There are 56 ways in which Bernardo could have selected a group of 3 numbers. Do we agree? So it could be like 186, it could be 281, it could be 315, like that. There are a total of 56 such entities. Do you agree? Now, once Bernardo has picked, so Bernardo is picking first, let's say, he's going first. He's picking something. He has no restriction at all. So we are looking at the probability that both Bernardo and 1 over 56, itna hi hai baat, right? Bernardo can pick anything, 1, and you have to pick one of those 56. That's it, right? Does it make sense, Ananya? Right? So E is just 1 over 56, and therefore this is 1 minus 1 over 56 by 2, which anyone can simplify. 55 by 56 into 2. 55 by 112. Okay, so does this make sense? Now this is with 8 and 8. Now I'll let you guys think. Maybe for the next class we'll discuss. Suppose it's now you're introducing 9, right? So you can make it as an extension of this problem by saying when Bernardo picks, there are 2 cases. Either just imagine he's not allowed to pick 9, in which case it's this problem that we just solved, or a case where he is forced to pick 9 for sure. Those are the only 2 cases, right? Right? It's like one of those examples I gave in the team of 16 in cricket. You have to select 11. Like how many different ways? You can pivot on one particular person and say either he's there in the team and then select the remaining 10, or you say this guy is definitely not there in the team, therefore exclude him. So of the remaining 15 people, you select 11. Same idea. You can split into 2 cases. Does this make sense, guys? Right? So I'm not going to discuss the case with 9, but we'll keep it for next class. But come back and think about this. Now that you know the base case as 8 and 8, can extend it on it to find the 9 and 8. Okay. That was question 7. Question 8. What is the probability that ABC plus AB plus A is divisible by 3? Okay. Again, one of the harder questions, but even if you didn't do it fully, I want to hear how your approach was. Ananya, did you try something on this one? What did you do?
I wasn't sure how to go about it, but since they are divisible by 3, and then I'm not sure. I just like noticed that the 2010 is also divisible by 3. So
Correct.
then you have only like a remainder of 1, 2, or 0, like from all of the, because like it's the ending. But then
Correct.
I don't know what to do with
Yeah,
that.
that's a good observation to start. So basically, she said 2010. 2010 is a multiple of 3. Therefore, if I line up the numbers 1, 2, and 3, 4, 5, and 6, right? 7, 8, and 9, all the way till 2008, 2009, and 2010. So she's saying the first column is all these numbers which will leave a remainder of 1. The second column will leave a remainder of 2. The third column will be the numbers which leave a remainder of 0. So as far as remainders are concerned, the magnitude of the number does not even matter, right? Because it's going to repeat in cycles. So whether it's 2010 or 20,100 should not matter, right? We should not be scared by the bigness of the number, largeness of the number. Okay, so now, any ideas? That's a good start, Ananya. Kunsh, you want to add anything? Or Anahat, you want to add anything? Mihan, how can we approach?
Yeah, so basically we just need A to be divisible by 3, and then I don't think any of the rest matters.
Very
because
good.
none of the numbers will be divisible by 3. So now we just need to find the number of numbers divisible by 3 between 1 and 2010, which should be 670, I think.
So which is
That's
1/3, no?
my
Because
idea.
equal number of numbers are divisible by 3, no? Because as we just said, it's
1/3.
symmetrically placed. What you said, you went in a rush, Anahat. You meant if A is divisible by 3, then surely it's divisible by 3, because this expression we have is A into
Yeah.
BC plus B plus 1. If A is divisible by 3, yes, I don't care about B and C. But A need not be divisible by 3. That part you're missing out.
A is not divisible by 3, then ABC plus AB can be anything. When we add A later, then we'll get a remainder. So A has to be divisible by 3.
No, not necessary. If A is not divisible by 3, BC plus
Wait,
B
both of
plus
them
1.
cannot be divisible by 3.
Sorry,
Not
sorry.
really.
Oh, no. Sorry.
Yeah. So I can always have an example where BC plus B plus 1 is not divisible, is divisible by 3, right? Ananya, you was adding anything to it? Or you're saying
No.
the same, right?
Yeah.
So just to summarize, we can split into 2 cases. A is divisible by 3. A is divisible by 3. Okay. And A is not divisible by 3. Okay. If A is divisible by 3, like you said, there's randomly and independently selected with replacement. So you have enough keywords to say that A, B, and C, they're all really independent. They can be the same numbers also. For A to be divisible by 3, you can have 1/3 of this collection are all divisible by 3. He's nicely packed it says that it's like a rectangular arrangement of all the numbers, right? So 1/3 of them are in the last column, which is divisible by 3. So this is 2010 last. Okay. So that's 1/3 into don't care. I don't care about B and C, which is 1, right? So which is 1/3 into 1 for this part. Yeah, Ananya, you with me? And for this part, we are saying it's 2/3 probability that A is not divisible by 3. Then all depends on B and C. Okay. So, and I will do this problem separately now. So we'll just focus on BC plus B plus 1. And we are asking ourselves, when will this BC plus B plus 1 be divisible by 3? Okay. Agreed so far? Okay. Now, again, let's take a small detour, right? So for example, let's say I'm dealing with a number 59 times, let's say B is 59, okay? And C is, I don't know, 74 or something, right? Or I'll keep 73, okay? 73, okay? So 59 into 73 plus 59 plus 1, okay? And then I have to do and just check if it is divisible by 3 or what the remainder is and all that, right? It's a pain. But I don't need to do this to find just the remainder, right? If I want to look at this expression BC plus B plus 1, right? So all I care is this is some multiple of 3 plus some remainder, right? It's 57 plus 2. 57 is multiple of 3. And then this is 72 plus 1. And then similarly, this is 57 plus 2. And then this plus 1, of course. Now, as far as remainder is concerned, 57 being a multiple of 3, 57 into 1 will not leave any remainder. 57 times 72 will also not leave a remainder. 72 times 2 will also not leave a remainder. The only thing that will leave a remainder is the combination of 2 times 1. Right? And similarly, the only thing that matters is the 2 here. And of course, the 1 here. So all that matters is effectively 2 into 1 plus 2 plus 1, which is the remainder of 5. And 5 is nothing but equivalent to 2. When you say divide by 3, the remainder is 5. It's like saying effectively you can subtract off another 3 and the remainder is 2. So such a big number, instead of calculating and multiplying and all that, I know it leaves a remainder of 2 very simply. Because all that matters is how the remainders of each of them combine, multiply, and add and all that. Does this make sense conceptually, all of you? Okay, now it's easy to figure out, right? So let's put B on one dimension. So B, when you divide by 3, let's say it could leave a remainder of, so I'll put B here, I'll put C here. I'll just draw this and then you'll see for yourself. So this is B. Okay, and this is C. Okay, so B could leave a remainder of 0 or 1 or 2. Okay, and similarly, C, when you divide, could leave a remainder of 0 or 1 or 2. Okay, so let's now fill this grid. Okay, so we'll make a grid here, so it's easy. Okay, so let's fill this grid. We'll evaluate this expression BC plus B plus 1. So for 0, 0, it's 0 plus 0 plus 1. So the remainder is 1 here. You agree? Similarly, with B is 0 and C is 1, it's 0 plus 0 plus 1. Right? And similarly, the third one. If B is 0, then the first 2 terms anyway vanish. So it's a remainder of 1, 1, and 1. Okay, what I'm trying to do is, there are only 9 possibilities. Of that, I'm looking at a fraction where the remainder is 0. That's my plan. So that's what I'll put here. The fraction of the 9 cells that I'm going to fill, what fraction of them are divisible by 3? Does it make sense? Are you able to connect it now? Now, I'm moving to the second column. B is 1 and C is 0. So this is 1 times 0 plus 1 plus 1. So remainder of 2. B is 1 and C is 1. So it's 1 plus 1 plus 1, which is 3, which is effectively 0. Aha, I've got 1 now. So if B is a remainder of 1 and C is also a remainder of 1, then the final number is divisible by 3. Similarly, if B is 1 and C is 2, I get 2 plus 1 plus 1, which is 4, which is effectively 1. So that won't work. What if B is 2 and C is 1? I get 2 plus 2 plus 1. Sorry, B is 2 and C is 0. Sorry. So 0 plus 2 plus 1, which is 3. That works. 3 is effectively 0. B is 2 and C is 1. So 2 plus 2 plus 1, which is 5, which is effectively 2. Won't work. And B is 2 and C is 2. So it's 4 plus 2 plus 1, which is 7, which is effectively a remainder of 1, right? So 7 means I can subtract off 6. So of the 9 squares that I filled, only 2 of them were cases. And I'm literally have to count how many, because it's all symmetric, right? We have equal number of numbers, equal number of B's, which will leave a remainder of 1, which will leave a remainder of 2, which will leave a remainder of 0. Likewise with C also. Therefore, it's symmetric. That's how he has given the number 2010. Had he not given 2010, had he given 2009, then it would have been a big pain, because there's a small fraction of numbers, right, difference between the two. And then you have to deal with big numbers. But because it's symmetrically laid out, now it makes the problem much easier. Does it make sense, guys? All of you? Yeah. So this is 4 over 27, right? So the final answer is 1 over 3 that we got in the first part, and then 4 over 27 in the second part. So they add up to how much? 9 plus 4, which is 13 over 27. So almost half the probability that this expression will be divisible by 3. Right? Okay. So that was question 8. Any doubts in this one? Make sense, all of you? Kunsh, Vihan, all okay? Anat?
Yes, sir.
Okay, let's go to homework 7 now. Open it up. Oh, sorry, this is homework 7 or yeah, this is homework 6. Yeah, open up homework 7. Okay, real numbers X and Y. Real numbers X and Y, blah, blah, blah. What is X plus Y? Yeah. Kunsh, did you get anything on this?
I got 2, sir.
2. Okay. What about you, Ananya?
Yeah, I also got 2.
So fairly easy, right? I'll just move everything to one side. X square minus 10x plus Y square plus 6y. Okay. And then I'll add something to complete the square. So it will become X minus 5 whole square, right? So on the right-hand side, I have minus 34. Okay. So I'll add 25 now to the right-hand side. And then Y square plus 6y, I can complete the square by adding 9. So it becomes X minus 5 whole square plus Y plus 3 whole square equal to 0. Yeah, Bihan, how do you complete from here?
So basically you have to open the bracket. To open the bracket, you have to get.
Why do you have to open the bracket? In fact, we sent them inside the bracket. We completed the square so that we can write it in this form. And what is the advantage of writing in this form? Yeah, Ananya, go ahead.
So you can just, since you have 0 on one side, you can say that
And so if you get x is equal to 5 and y is equal to minus 3.
But why
5
does X have to
plus
be 5 and why does Y have to be minus 3?
So that's because if you
He's frozen to me, right? Okay. Ananya, can you complete?
So
Why does
next-
X have to be 5 and Y
Right.
have... Sorry, Bihan, you are frozen. Please repeat. What did you say?
So I'm saying if you end up opening the bracket, you'll just
I agree that X equal to 5. Okay.
and then if you get plus minus.
No,
Hello?
you keep freezing. I agree that X equal to 5 and Y equal to minus 3 will work. But why is that the only possibility?
So I'll type it in chat because I'm lagging out when.
No, it's fine. It's fine. You can call it out so that everyone can hear.
So I'm just saying that if you open the bracket,
Yeah.
wouldn't it just become plus minus 0?
Yeah.
And then that just gives you
So
and then
what do you mean becomes 0? So the right hand side is 0. So I have X square minus 10x plus 25 plus Y square plus 6y plus 9 equal to 0. This far I
Yeah.
agree, which you can simplify as this, or you're saying, let's leave it in the expanded form also. But how do you infer that X equal to 5 and Y equal to minus 3?
so basically what I did from here is I took a square root of both sides, right?
Yeah.
And then I got x minus 5 plus y plus 3 is equal to 0 because square root of 0 is just 0.
But square root of the left hand side is not X minus 5 plus Y plus 3, right? This is like saying square root of A square plus B square is A plus B.
So then I just got lucky with my answer.
Yeah, but if you go with that, then X minus 5 plus Y plus 3 is 0. I agree X equal to 5 and Y equal to minus 3 works. But by that logic, X equal to 7 will cause this to be 2. And then Y equal to minus 1 will, or rather minus 5 will cause this to be minus 2. Why won't that combination work? Right? We won't get X minus 5 whole square plus Y plus 3 whole square equal to 0 in that case, right? Okay, Ananya, can you complete? What were you saying?
that it would be 5 because 5 minus 5 square would be 0 plus negative 3 raised to 2 will also be 0 with.
I agree that 5 and minus 3 happen to work, but why is that the only solution?
So that is not the only solution, sir, but
Then what
that's
is
for
the...
a solution.
Okay, so since that
Oh yeah,
works,
sir. No,
But then in the end, you have to add it anyway, so we'll get the.
okay, it is the only solution because X minus 5 whole square is a non-negative quantity, which means it's 0 or more. It's a perfect square. or rather some square, right? Real number, so some square. This is also 0 or more. The only way in which the sum of two quantities, which are both 0 and more, adds up to 0 is if individually each of them is 0. And that happens only when x equal to 5 and y equal to -3. Does it make sense, guys? Vihan went away, but Ananya, does this make sense? So in fact, this is the only solution, x equal to 5 and y equal to -3. Only then each of these terms will be 0 plus 0, which will add up to 0. If x is anything other than 5, x minus 5 whole square will be positive. And then if y is anything other than -3, that will be another positive. That's it. The sum will be some positive number, right? So for the sum of two squares to add up to 0, each of these squares has to be individually 0. Does it make sense, guys? Kunsh, you with me?
Yes, sir.
And therefore it has only one solution, which is this. Okay. That was question 1. Question 2. Yeah. Anahat, what did you get on question 2? You're on your video is off, Anahat. What's happening? Anahat Singh, are you there? Okay, all right. Vihan, what did you do on this one? Question 2.
So I didn't understand what the clove sign
It's
was.
just some symbol, right? So the standard symbols are plus minus into division, but an author can come up with his own symbol and define a formula, right? Tomorrow I can come and say, I'll define A and I'll put a man's face here is A power B plus B power 2A, something like that. I can make up some formula like this, right? Like that, the author has come up with a clever sign and said he's defining for this problem, this particular relation. So based on that, you have to answer. That's it. Right. So basically he's asking, so this will be what? The left-hand side will be x square y minus xy square, correct? Based on the formula he's given. Yeah, Ananya, you're saying?
I got one line.
Okay, one line. Okay. So basically x square y minus xy square.
I also got one line.
You also got one line. Okay, good. Okay, so x square y. So let's simplify. So this is 2x square y equal to 2y square x. I can cancel off the 2. I can cancel off the x. I can cancel off the y. So essentially, x
Yeah.
equal to y, right? Which is one line, which is wrong. What is wrong? X equal to y, right? Which is just one line, but there's some small mistake. Big mistake, actually, but
So you can't cancel x squared and then y squared
why not?
because the x and y are different. It's like canceling 2 raised to 2 equals to 3. I mean,
No,
that
I'm
will never
cancelling
happen,
the
but
x with the
generally
x.
you can't.
So this is x square y equal to xy square. I'm cancelling this y with this y square as one of them. And I'm cancelling this particular x with this x square. So I'm having x equal to y, right? What's the problem?
Oh, all right, sir.
But yes, there is a problem in cancelling. But what is the problem? What does cancelling mean, guys? Ananya, when I cancel x square y equal to xy square.
So the dividing by 0 thing, I get how that could be a problem. But here, if either is equal to 0, then
Yeah.
let's say xy is equal to 0. There also, it's not possible to get xy equal to 0 unless x is equal to 0 and y is equal to 0.
Okay,
that
and then
means
who's
0
forbidding you? And who's forbidding you from putting x equal to 0 or y equal to 0?
No one, that's the point. No, so it will just still stay at 0, 0. You can't basically usually when you can't cancel on both sides because the problem happens that you miss one set of cases since it could also be 0, but here 0, 0 is a point on the line. So
And what shall I say now? Okay. All right. Okay, x square y. So till here we are okay, right? Minus y square x equal to 0. Okay. Yes, as he rightly said, you cannot divide by 0. And in cancelling, that's what is happening, right? When you're cancelling x square away equal to xy square. When I cancel off x, that means I'm dividing both sides by x, which I cannot do when x is 0. But what he's missing is, okay, so let's say it's always better to keep everything to one side and keep 0 on the other side. That way you won't go wrong at all. I can take x common outside, y common outside, and put x minus y here. Always get into the habit of doing this. This way you'll never go wrong. This is product of several independent quantities. X is a quantity, y is a quantity, x minus y is a quantity. Product of these three quantities is 0 when either one of them is 0. So x equal to 0 and y equal to 0 do not have to occur together on Earth. X could be 0, namely the entire y-axis. Y could be 0, namely the entire x-axis. Or x minus y equal to 0, which is the 45-degree line that I just drew. So the answer is the x-axis, the y-axis, and this line. Therefore, 3 lines. Does it make sense, guys? Anath, you with me?
Yeah, I missed that.
Yeah? Ananya, did you understand fully? All of you. Kunsh, Vihan? Okay.
Yeah.
So x and y both, yes, you're right that you picked on 0, but they don't have to be simultaneously 0. X could be 0 and y could be anything really, which is why any point on the y-axis. And similarly, y could be 0 and x could be anything really, which is why any point on the x-axis also counts. Right? Okay, so back to what I was saying. Always never cancel, get everything to one side, set the other side to 0, and then look at each unit separately, right? And forcefully put brackets. That way you'll see what's happening. X is just one multiplicative unit. Y is just one multiplicative unit. X minus y is another multiplicative unit. All of these 3 multiply. Okay, question 3. Quadratic. Okay, who wants to take this one? Kunsh, did you do this one?
So I tried, but I couldn't get it. Right?
So I
Can you
know you
explain
have to
how
use
far I got?
discriminant for this, right?
Yeah, you have to use discriminant. Yeah. And the discriminant would be what in this case?
Minus b square minus 4ac, but
Yeah, that's the discriminant
I
always.
wasn't sure how to solve it because you didn't have any numbers to deal with.
When does a quadratic equation have exactly one root?
When the discriminant is equal to 0.
Exactly. So b square minus 4ac has to be 0. Ananya, did you go through my quadratics recording and all that earlier recording? Yeah. So you're okay with quadratics, right? Reasonably okay with quadratics?
Just somewhat. I'll just.
Okay. So okay, just quickly, like ax square plus bx plus c, when you set equal to 0, you'll have 2 roots, right? Minus b plus or minus square root of b square minus 4ac whole upon 2a. So this b square minus 4ac is what's the discriminant, right? So that will determine whether you have 2 roots, typically 2 roots. When d is greater than 0, let's say d is 23, square root of 23, when you plug in here, I have plus or minus outside, and therefore there are 2 roots. Right, square root of 23, by the way, is only a single number. It's always the positive square root of 23. But because of the plus minus outside, I have two values for the roots. Roots meaning the values of x, which will solve this equation, which will make this equation valid. Now, if he's saying there's only one root, that happens when discriminant d is 0. So that it becomes minus b plus or minus 0 upon 2a. So it's minus b by 2a. The two roots are both the same value, namely minus b by 2a. And if d is less than 0, that's when the quadratic equation does not have any roots at all. Okay. Now, in this case, it's the middle wala case where discriminant is 0, which is why it's minus b plus or minus 0, namely just minus b upon 2a. So the two roots are coincident and they are minus b by 2a. Okay. Now, they are saying that a, b, and c are in arithmetic progression. Right? So let's keep the middle one as b. Let's keep b as b itself. And c is b minus d or something. Right? C is lower than b, right? This is b, which is b itself. And a is b plus d. So that you have some symmetry, right? So this is a, this is b, and this is c. So always symmetry helps. So what is my discriminant now? B square minus 4ac. So it's b square minus 4 into a into C. So this discriminant, how much is this? B square minus 4 into B plus D times B minus D is B square minus D square. Okay. B square minus 4 into B square minus D square. Now this discriminant in this problem is given to be 0 because the roots are coincident or exactly one root. Okay. So let's simplify this. I can get B square minus 4B square as to this side as 3B square. And this side I have 4D square, which means my D is root 3B by 2. It could technically be plus or minus, but we are assuming D is a positive number, right? Because C will be less than B. So the sequence is like this, right? So which means we want D to be a positive number. Yeah. So D is root 3B by 2. You guys are with me so far? Okay. And now what do we have to calculate? The two roots are, we just saw, right? Minus B by 2A. What is this root? Namely the two coincident roots. What is that value? So B is just B. And A, as we just saw, is B plus D. So B plus D. So A is what? So A is B plus root 3 by 2 times B. So A is B times 1 plus root 3 by 2. Okay, so this is B into 1 plus root 3 by 2, right? Okay, so that's what we have. B and B gets cancelled. Therefore, you don't need any numericals in this case, Vihan. And 2 and 2 can expand here as 2 plus root 3. And just to avoid conjugate, just to avoid denominator, I'll multiply and divide by 2 minus root 3. So the denominator becomes 2 plus root 3 times 2 minus root 3, which is 4 minus 3, which is 1. And the numerator becomes root 3 minus 2. So which is this guy. Yeah, makes sense, all of you? Kunsh, you with me?
Yes, sir.
Ananya, makes sense, all of it? Okay. Question 4. A, B, and C be three distinct one-digit numbers. What's the maximum value of the sum of roots of this equation? Yeah, Ananya, did you try this or?
I don't know how to go about.
Okay, Anahat.
No, I haven't done.
Sorry, what did you say, Anahat? You did not try. You didn't have time to try. Is that what you said? You unmute and speak very quickly and then put back and mute.
So I think there's just some lag when my voice goes, so that's why between unmuting and muting it doesn't.
Okay,
Yeah,
but
I haven't attempted.
you have not attempted. Do you guys want to attempt this now? Right, Kunsh, Vihan, you have also not attempted, I guess, right?
Yes, sir.
Okay, so I'll give you a hint, right? I mean, it's not a big hint. You can see that x minus b is common. So it's not a difficult problem. That much I can tell you guys. Can you try it, please? I'll give you 1 minute to try it. X minus b can come out common out, Ananya. Write it as x minus b times something else. And then see where you can go from there. Yeah, okay. Any luck, guys, so far? Ananya?
Not really.
Okay, all right. So let's do this. X minus b can come outside. So it's x minus b times x minus a plus x minus c equal to 0. Okay, so it's x minus b times 2x minus a plus c equal to 0. Or so what are the roots of this? So it's always better to write as x minus something. So I'll get the 2 outside here and write it as x minus a plus c by 2 equal to 0. So the two roots are b on one hand and a plus c by 2 on the other hand. So far, you guys are with me? All of you with me so far?
Yes, sir.
Okay, so now he's talking about maximum value for the sum of the roots. So the sum, which is b plus a plus c by 2. And each of them are single digit, three distinct one-digit numbers. So one-digit numbers means I'll include 0 also, but anyway, we're looking to maximize, so 0 should not matter. So A, B, and C come from this collection. So, and if you want to maximize, then obviously we have to allocate 7, 8, and 9 to A, B, and C. Only then there'll be maximum. But how do we allocate B plus A plus C by 2? So our hunch is leaning to give a bigger weight to B, but let's actually formally do that. So this is 2. This is 2B plus A plus C. Okay, so I can write this as A plus B plus C plus additional B by 2. Now, 7, 8, and 9, whatever way I know I have to allocate for A, B, and C, because only then that will maximize it. So whatever way it is, the sum of A plus B plus C will be 7 plus 8 plus 9, which is 24. But this extra is what we have freedom. So you might as well allocate B to be 9 to maximize that. And A and C could be 8 and 7 in any order. Does it make sense? So this maximum is 16.5, 24 plus 9 by 2, which is 16.5. Okay. On the other hand, suppose it says what is the minimum value, and then in its minimum value, then they have to qualify whether 0 is allowed or not. Let's say 0 is not allowed. Okay, A, B, and C are three distinct one-digit positive numbers, something, let's say. The question is like this. Then you'll come all the way, you'll do the same thing till here. And then finally, you will say A, B, and C have to be some numbers between 1, 2, and 3 to have a minimum sum, minimum possibility. Therefore, A plus B plus C, you will arrive at this point, A plus B plus C plus B by 2. You want to minimize A, B, and C, whatever way you allocate for 1, 2, and 3, their sum will anyway be 6. So you want 6 plus B by 2. So you'll allocate B to be as small as possible. You'll allocate 1 to B, and then A and C to be 2 and 3. So it'll become 7 by 2 in that case. Exact reverse approach. Just like we've allocated A to be 9 B to be 9 in this case. In the other problem that I made up just now, you'll allocate B to be 1. Okay, that's question 4. Question 5. Five positive consecutive integers starting with A have an average of B. Yeah. Kunsh.
So for this one, I got a
You got what, sorry? You got frozen, that much I know. That's what you got. All right. Okay, who wants to take this? Vihan, follow.
So I can try.
What do you mean you can try? You did not try, that means already. You did not do it as
So I
part of
haven't
homework.
done this question because but is it A plus 5 by any chance?
I don't know.
Because
we have to do it, but tell me, walk me through this. Yeah.
so if 5 positive consecutive integers have starting with A have an average B, it's basically saying A plus 1 plus A plus 2 plus A like that. So that's 5A plus 1 plus 2 plus 3 plus 4 plus 5, which is 15. So it's 5A plus 15. Oh no, it should be A plus 3 because 5A plus 15 divided by 5. So A plus 3 should be the answer. I
It's
think.
not. It's not 5a plus 15. You're making a mistake. So it's
Shouldn't be
a is starting, right? 5a plus 10, right? So a plus 1, a plus 2,
Oh
a,
yeah.
Okay.
Oh,
and then
yeah.
you'll arrive at a plus 2 here, which is b. But then, yeah, it's fine. But it's always good to use symmetry. So if 5 consecutive numbers are adding up to have an average of b, that means the middle one is b. The one prior to that is b minus 1. The one prior to that is b minus 2. And by symmetry, we have b plus 1 and b plus 2 on this side. That way, it's much easier. And this is my a. This is my a. So b is the middle one, 2 on either side, adding up to 5 numbers. So the left extreme is your a. So now you have this.
So
Yeah.
How do we know that A is B minus 2?
Because that's what I'm saying. 5 consecutive positive integers starting with a have an average of b. So for 5 numbers to have an average of
right,
b,
yeah.
must be b with
Yeah.
2 on either side. Yeah.
Yeah.
Yeah. Now
So
the
I
question
missed-
is, yeah, what is the average of 5 consecutive numbers starting with b? So 5 consecutive numbers starting with b will be, the average will be b plus 2, because there'll be 2 numbers here and there'll be 2 numbers here, b plus 3 and b plus 4. I'm not writing it. The average will be b plus 2. Now all you have to do is write b plus 2 in terms of a
Which
plus
is A
something.
plus 4.
Yeah, a plus 2 plus 2, which is a plus 4. Easy question. Okay, Ananya, makes sense? Hope you got this one. Okay, or did you do it yourself, or you got this now?
No, I got it now. I wasn't sure how to the relation between A and B.
Okay, all right. Maybe this is the last question for the day. Y-intercepts P and Q have a sum of 0. What is the area of triangle APQ? Anyone on this one? Have you guys attempted it? If not, we'll directly discuss then, since we have only 3-4 minutes. Has anyone attempted and got an answer? Kunsh, have you?
So I tried it, but I couldn't figure out how to start it. So how to
Okay.
get started on it.
All right, let's do this, right? So let me draw x-axis and y-axis. So x-axis, y-axis. Okay, so there is a point 6, 8. Okay, so let's say 6, 8 roughly on this grid is somewhere here. Okay, 6, 8 is here. Okay, now I have the y-intercepts. Okay, this is the point A, 6, 8. Okay, the y-intercepts P and Q of 2 perpendicular lines have a sum of 0. So first I'll draw some random perpendicular lines. So let's say I'm able to draw a line like this, right? And a line like this, which are perpendicular. Okay, now just roughly I'm drawing, right? This top point is P, this bottom point is Q, let's say, right? This is P and this is Q.
So
Yeah.
Can we assume that this makes a right angle triangle at point A?
In fact, it does, right? He says 2 perpendicular lines intersecting at the point. So this is right angle only. This is right angle only, right? Okay, but the way I've drawn is intentionally not nice. Why? Because the y-intercepts of P and Q have a sum of 0. But in this case, P looks like a big positive number, Q looks like a small negative number, which means my tilt is not all right. Right? So P looks like maybe, I don't know, 11. Q looks like -1. They're not going to add up to 0. So you want P and Q to be direct negatives of each other, which means I'm going to tilt it out a little bit. Let me just control Z out of this. Can I control Z after? Okay, so now I know my tilt has to be little steeper. So I'll take, I mean, I'm not asking you to draw a perfect diagram, but I'm just asking you to get a feel for it. So maybe something like just a minor tilt here, maybe like this. Okay, and maybe the perpendicular is like this. Again, you don't have to draw a perfect diagram. Something like this seems reasonable, right? So that this is P and this is Q, and this coordinate and this coordinate exactly cancel out, right? Positive and negative, and they add up to 0. Does this make sense? Right? And this is 90 as you said. Okay, so now so let's draw this. connected here. So this is 6, 8, which means what? This height is 8 from here to here. So height from here to here is 8. And this is 6. Okay, so let's call this small gap as X or something, which means this whole thing from here all the way till here should also be, I don't want to keep X, so X is confusing, right? I'll just keep some number like A or some B. Okay, so 8 plus B. So B is a positive number. So this length is 8 plus B, namely the coordinates of Q are minus of 8 plus B, comma 0, or rather 0, comma minus of 8 plus B. So the coordinates of Q are 0, comma minus of 8 plus B, if at all you want to understand. But lengthwise, you understand this, right? 8 plus B and okay. Now you can see just by symmetry, not by symmetry, by similarity of triangles. So let's call this point as R or something. So this, okay, I'll just mark this R. So if I look at the triangle PRA, okay, and look at the triangle AQR, both are similar. You can see that, right? In fact, in any right angle triangle, I've told you this, in any right angle triangle, if I drop a perpendicular from here to this, that'll divide into 3 different similar triangles: the small triangle, the medium triangle, and the original whole triangle. All 3 will be similar. And it's easy to see that, right? So because if this is theta, this will be 90 minus theta. Okay, and therefore this will be 90 minus theta. And this will be 90, this will be theta. You can see that all 3 triangles have theta, 90 minus theta, and 90. Anand, are you with me so far? Okay, so now
Yes.
we can use the ratio of side lengths. So in the small, in the triangle PRA, let's say the smallest side is B. Just visually I can see, right? B upon 6, the smallest upon the medium, B upon 6. Whereas in AQR, the smallest, this is B, the top portion is B. In the triangle AQR, the smallest portion is 6. And the biggest portion is 8 plus 8 plus B. Are you guys able to imagine this? So this whole thing is the medium side of that. So 6 upon 8 plus 8 plus B. And these 2 triangles are similar, which means B upon 6 equal to 6 upon 14 plus B. So 36 equal to, so not 14, 16 plus B, sorry, 16 plus B. 16 plus B. So 36 equal to B into 16 plus B. You don't even have to solve this quadratic. You can easily guess, right? 36 is got by product of two numbers that are small and big. So 2 and 18 makes sense. 16 plus 2 is indeed 18. So B is 2. And once you do that, then we can figure out everything else, right? So B is 2, this is 2, then therefore this height is 10. And then area of triangle APQ. APQ is, I can use half base into height. PQ is the base. PQ becomes now 10 plus 10, which is 20. Right? And the height is just 6, namely AR. This is the height. So the area becomes half into base into height, which is 60, one of the choices. Does this make sense, guys? Yeah? Okay, work it out yourself later, all the questions, whichever you didn't get. Okay, let's stop here for today. We'll meet you next class. Chalo, bye.
But